So what if we are not given two equations and asked if they are inverses of each other? We're just given one equation and told find the inverse of this equation. Well, there's a four-step method we're going to use here, and the steps are this. It's called the switch and solve method. So here are the switch and solve steps. Step 0, verify that the function is indeed one-to-one. So draw the picture or think about the picture and make sure it passes the horizontal line test. If it doesn't, you're done because it's not one-to-one. Only one-to-one functions have inverses, and this method will work for that. If not, again, you're done and it's great. Step number 1. If f of x is in the problem, replace it with y. All right, so we want to use y, not f of x, but a lot of times problems start with f of x, we replace it with y. Then the switch. This is the fun part. Where you see x, replace it with y. Where you see y, replace it with x. And all instances. Typically, there'll be one y in the problem, and there may be many x's, though. So when you get done, there should just be one x, and there could be multiple y's. Then, step number 3, solve for y. Figure out what y is. And finally, step number 4, once you've found y, replace it with the inverse of f of x. If you started with the inverse of f of x anyway. If you didn't, we'll talk about that as well. But those are the steps that we want to use to solve or use the switch and solve method. So let's go ahead and look at example 5 on page 279 and see if we can employ this fun switch and solve method. Let me take our steps and minimize them so that we still have them, but we have more space to work on. Got to love the power of Microsoft Paint 3D here, which I've been using. All right, so our steps are in place and ready to go. And so I'm looking at example 5 on page 279. Part A says f of x equals 2x minus 1 divided by 3. Okay, so let's get into our switch and solve steps. Step 0, verify the function is one-to-one. Is this a one-to-one function? Yes, this is a one-to-one function because x is to the first power here. This is basically a line. Even though it's divided by 3, another way we could look at this would be 2/3 x minus 1/3, which we would know to be a line. And all lines are one-to-one functions. So it does pass step 0. We are verifying indeed this is a one-to-one function. All right, then step 2 here. It says replace f of x with y. So in other words, y equals 2x minus 1 over 3. All right, so that's step number 1. Step 2, the switch. We switch y and x. So there's one y. This is now going to be x. And there's one x. That's now going to be y. So it's gone from y equals 2x minus 1 over 3 to x equals 2y minus 1 over 3. All right, and then step number 3, solve for y. We want to solve for this y right here. So step number 1 to do that is to multiply both sides times 3. That will eliminate the 3's on the right and give us 3x equals 2y minus 1. Then we're going to bring this 1 over, so it's going to be 3x plus 1 equals 2y. And then we're going to divide both sides by 2. And so it looks like y equals 3x plus 1 divided by 2. Hey, we're looking really good here. The step 3 has been done. And step 4 now says, hey, any y that you have, and replace with the inverse of f of x. So our final answer should be the inverse of f of x equal to 3x plus 1 over 2. And we can look at that and say, is this indeed the inverse? Well, I mean, the method certainly says it is, but everything should feel like it as well. Let's go back to the original thing. Up here, the original equation had 2x, 2 times x. Here we have divided by 2. The original equation was divided by 3. Here we have times 3. The original was minus 1. We have plus 1. So every operation that we've done in the original has been undone in the inverse. And this is a fun method. I enjoy doing this method quite a bit just because I like saying the switch and I like using the sound effect. It does help to do the switch there. So feel free to do that same sound effect when you're doing it. It does help, I think.